Hello. Let me move this down a little bit. Welcome back. I am a sleepy person again, so this may be a short stream. We'll see. Last time we got we built a ring buffer. Let's kill off the dead code here. We're using draw ring 3 now. Draw ring new 3. 3. I wish my thing would stop clicking. So draw ring new 2 is dead. Build ring indices is not dead. Drawing new is dead. Build ring vertices, build ring indices, draw ring, build all ring indices. Yeah. I think there might be one more old draw up here. There's 2 vertex flags, and then there's a commented out draw ring and 2 vertex. And a commented out and an if zeroed out one. Okay. Let's see, make sure that builds. Okay. So that's what we did last time. And this time we're going to fix the code to generate the data at each vertex, which is this giant mess, but that can be done much simpler. So let's do it much simpler. Center X and center Y are now 0 always. 2 vertex flags. Right, 2 vertex flags gets called with negative radius, radius, radius. So we can now just call it with radius. And we can say int OX0 equals negative radius, OY0 negative radius, X1 equals radius. And we'll get rid of those in a second, but I just want to keep the code consistent for now. So that's int radius. Do I listen to some tunes when coding off stream at least? No. I used to listen to music all the time when programming, even some like music that is very abrasive and you might think distracting. Music with lyrics, not a problem. And then all of a sudden, I don't know, 10 years ago or so, I stopped listening to music at all, pretty much, not just when coding. So, do we even use center X? Yeah, we do. Okay. So, we can get rid of that. Let's not do that. Let's fix the logic to not be cut and pasted. Let's do that instead. Okay, so how do we want to do this? Let's just if zero out the old logic. Oh, this is so annoying, the creaking microphone. I don't know what part of it was creaking, so I don't know if that fixed it or not. Okay, so what we want to know is what ring it's in, but what that really just means is how far is it from the edge. So ring X is radius minus absolute X. Ring Y equals radius minus absolute Y. Then, what do we do? If it's in ring 0 or ring Y, if I recall correctly, this one was a special case, and then it's alternating pairs of non-special cases. So if ring X equals 0 or ring Y equals 0, oh, we don't use collapse anymore. That's right. Else, all right, well, let's just copy the old logic for the first 3 cases and then figure out how to make it automatic. So then it's if ring X equals 1 or ring Y equals 1. You do this, then it's if ring X equals 2 or ring Y equals 2. Okay, so what we want to do is say else we want to say int ring equals STB min of ring X comma ring Y. I guess we can do that out here. And then it's just if ring is 0. And then this is if ring X equals 1, else. Okay, and then we want to say if ring is less than equal to 4, no, less than equal to 8, which actually we can put here. Then if ring and 1 equals 1, then it's this case, otherwise it's this case. So the step is if ring is 1, then step is 3. If ring is 3, then step is 2. So it's going to be something like 4 minus ring over 2. So ring is 0, 3. Then what's px and py? What was gx and gy? Shift is always called with 1, 0. Shift is always called with 0. So gx is just x. This is ring x equals 0. This is ring y equals 0. Why does this not say collapse y equals 1? Shouldn't it? Well, it doesn't matter because we don't use the collapse value anymore. That was weird that it didn't. But okay, yeah, we don't use the collapse values anymore. So this is if ring X. So we're in either like in the initial case this was ring 1. So we're either in ring 1 X or in ring 1 Y. So ring is 1. So then in ring 1 is ring X equals ring, or ring X equals ring plus 1. Is what that all works out to. But we don't use that anymore. We're just using this. So this is ring X equals ring. This is ring Y equals ring. This is step of 4 minus ring 1. So first time we hit this is 2, ring is 2, so ring chip like 2 is 1. Step 4 minus 1 is 3. That's the correct value we're supposed to get. So maybe that's right. I don't see any gaps. Is it morphing correctly? Looks like it's morphing correctly. Okay, let's expand the morphing to be 16. So the step now is 8, 7, 8. Plus flag is still that. Ground vertex. 8, 8. Maybe. Okay, seems right. Okay. So we can kill the old code. Because now we've got the nice simple code. And I think this case and this case are now actually the same. Yeah, they look the same to me. The dist is different, but the that's actually, I think, okay, because it's ignored in the. I think this one ignores it because it's forcing the. This one for step 8 gets forced. That's the one that has to match the outer neighbor, so it gets forced to 100%, and so the dist doesn't matter. Yeah. I don't think I have any useful comments about keyboard shortcuts because I use the built-in IDE defaults, and so there aren't a lot of interesting things here. So this is your case. Now can go through this path, and I believe that just computes everything correctly. So let's try that. Like I used to use VI, and then it was a lot more interesting things to say, but the default IDE BC6 thing just doesn't have enough keyboard shortcuts to do interesting things, I don't think. I mean, I'll tell you though, I can think of ones that I use, but I just don't think it's going to be that valuable. Okay, let's see how warpy it is now because we've pushed it out. So if we're at walking speed, see if we can still see some warping. There's one that's going to happen now. Yeah, I didn't see that happen at all. All right, so I don't think I use anything that I use that often, but this IDE has a pretty weird way to let you do copying of rectangles. So you know, like this. If I hit Control Shift F8, it gives me one of these that then lets me cut and paste just that subregion. And you know, every editor has some way to do that. It's important to know how to do it. One of the nice things about fixed width fonts is you can leverage that. There's Control U and Control Shift U. Control Shift U uppercases everything. Control U. But one pro tip that I have for all editors, works in every single editor. Every single editor that has undo, which is all editors. If you want to browse to the file and then come back to where you are, so what you want to do is you want to set a mark, go somewhere else in the file, and then go back to the mark effectively. But you don't know how to do marks. You know, if your editor even has that feature. It doesn't need to have that feature. What you do is you type something and you delete it, or you delete something and you retype it, or you select a space and press space, whatever. Now you've got in the undo buffer the thing you just did. That's actually why selecting a space and then pressing space is kind of optimal, because if you undo that, nothing happens because you replace the space with a space. Like, to make it clear, let's have 2 spaces and I'll replace 2 spaces with a space. So then you can see I undo it and it does that. But anyway, So that's how you set a mark, is you just do something in your thing. Then you go browse through the file, look at something else, and then when you want to return to your mark, you hit undo. And now your cursor is back to where you just marked. Of course, the mark doesn't last across doing other editing. It only works when you're browsing. That is a feature I use all the time. Undo. And you can also just do it in the abstract. It's, if you ever need to go back to the most recent place you changed something, undo and redo. That will return you to where the thing you just did was. Okay, and now this no longer needs shift. And I'm going to check that in. There's an FAQ under the video. Yeah, I mean, obviously, if the editor has a way to do it and you know that, you can just use that. But it's a nice little trick that undo just always has that side effect. Okay, so we got that working. I want to try this thing that I did before and then backed out, which is if I x or j and 1 equals 0, of alternating which direction the triangles go, so that the map doesn't have this weird bias along one diagonal. So we go, we want to reverse the diagonal, which is this to there, and this to there, and then we want to reverse that so the winding stays in the same direction. And then change this one to 1 and 1. I think that's right. So the problem with this is it doesn't match at the, let's bring in the, radius. That's going to have the morphing boundary too close. Okay. So now we can see the boundary. Okay. So the question is, did I fix the alternating thing? No. Yes. It's just not drawing it on one of them. So I have to order these a little differently. Why does that not? I don't know, maybe that. No, they're in the same direction. Oh, because I reversed both of them. Yeah. It has to go 0, 0, 1, 1, and then like 0, 1. And then the old ones was 0, 1, and 1, 0, and I swapped them, and that just became 1, 0, 1, 1, which is the exact same diagonal. this one needs to be 1, 0. But let's make the first vertex be that. All right. Yes, okay, now they're alternating. But they won't, but they'll pop at the discontinuity. I mean, at the LOD boundary, they will not match. Right, because the way we're morphing always to the same direction, and that causes them to all be facing the same way along that strip. And then when it switches, so alternating, that doesn't match. So now you need to go in here and say collapse flag, define direction X, 16 direction Y, 32 collapse flag if X and 2, I think, might have a guess. If X and Y and 2. And then this now has to shift by 6 because we have 6 bits of flags now. And when we extract the flags, we have to shift by 6. And then we have define dir X 16, dir Y 32. And when we do the direction, equals collapse flag and dir X 1:-1, collapse flag and dir Y let's make the parallel here clear, which catches a bug. And then this just becomes base dir.x, base dir.y. Hopefully that makes them collapse in opposite directions, but not necessarily matching the other one. Some syntax error at line 128. All right, what was the error? Syntax error, expecting parentheses at parentheses. Well, that's really helpful. Yeah, too many parentheses. Okay, well, that happened to match. That matches. No, okay, that one's not matching. That's swapping. So let's check a little more carefully, make sure that's matching. No, it's not matching. Oh, it's still... It's not morphing. Wait. Oh yeah, none of them are morphing in the wrong. The direction of morph it has not reversed. Why is the direction of morph not reversed? Base dir 1, -1, use base dir. So if these flags are getting set, let's move the randomness up here and then use that collapse flag equals bit field insert collapse flag 2 bits starting at 4 using the shift update. Just put random bits into the dir. Int, uint. Okay, yeah. No, they're always collapsing in this. Oh, no, wait. Here's a few collapsing in the opposite direction, but not very many. So that my randomness is not very good because it's not very random bits apparently. And then or there's something I'm doing wrong here. All right, let's double check. Are absolutely none of them collapsing in the wrong direction? Or in the opposite direction, rather? Yeah, absolutely nothing is collapsing in the opposite direction. So somehow I'm not setting dir x and dir y. Oh, it's because I masked out the flag. No, they're controlling each axis independently. Okay. That looks about right in terms of the effect of them splitting in a sort of tree-like fashion. Now, whether they actually line up is the question. So we have to see. No, they're swapping on that side. And then they're swapping on that side. They're swapping. Okay. So if we just swap all of the default LODs like this and leave the collapses in the same direction, then I think that'll match. Nope. Those are still swapping. Those are matching. No, those are swapping. Wait. How is it that... Oh, it might be different at different distances. I might have a logic error that... Okay. Let's put this back. Let's only look at the nearest one. Wait, that's definitely swapping. That's the same. That's the same. And this one's going to be swapping. No, wait. That's the same. Wait, what? That matches. That matches. That doesn't match. Okay. That's swapping. And that's matching. 3 of the 4. That doesn't make any sense. Okay, I wasn't looking at the right distance, probably. I was probably looking one out. Yeah, okay. That's swapping. Got it. Let's... So only draw the first 2 rings. So this is just the innermost, and now that's the first 2 rings. All right. Okay, that's swapping. That's stable. That's swapping. That's swapping. What? How is this possible? No, that's swapping. Why did I say it was stable? Look at that. Okay. It's swapping every other time. Oh, this just doesn't even work at all in the interior. The interior is changing which direction it's morphing. I'd have to move by 2. I'd have to move the interior by 2 at a time. I'm sorry, moving it 2 at a time. You would need to move it 4 at a time. All right, so it's not viable. We have to go back to just not doing it. Like, maybe there's a way to do it, but I don't know what it is. I'd have to work it out on paper, and I don't really feel like it. It's not that bad to have it be biased on the one diagonal, since the transition is... All right. So now let's do frustum culling. And I thought about this offline a little bit. And I think I have a plan for how to do it. And this is how the plan works. We're going to divide each of the things that we build into little subgrids that are 8 by 8. So where is the build ring indices? Okay. So why do we use radius squared? Oh, yeah. Why did I do it this way? Oh, because the indices, that makes the indices work. Okay, yeah. So we're going to say type def struct chunk. It's just a point. In xy. How many chunks do we need? If they're 8 by 8. So let's say a maximum of 256. And that would be what, 32 by 32, which would be 1024, which would be 8 kilobytes of stack. That's okay. Chunks of C equals C dot X equals I. We want the center of it, so it's I minus radius plus radius plus plus chunk size over 2. So first we'll find all the chunks, and then we will sort them. The count, the size of a single chunk, chunk compare. Point angle compare. Int point angle compare. Const void star p, const void star q. We cast those to 0.2. D1 equals a tan 2 of y x. D2 means a tan 2 x. Turn D1 is ST2. D1 is greater than D2. We'll just use that goofy idiom that I use. And so that will produce all the chunks. Let's just do this chunks once. Void compute chunks. Compute frustum chunks. And let's actually define the grid. this point of the center. This needs to be B, not A. Thanks, except D1 assigned twice. Thank you. This is now chunks of C.x0 plus chunk size. Compute frustum chunks. J and slot. All right, so now we computed all the frustums for little sub regions that we're calling chunks. That all has to go up here now. So then seg int num chunks equals slot. Now we can say for c equals 0 c less than num chunks. Actually, I wanted to use this one. And then for j equals 0, j less than chunk size. For I equals 0, I less than chunk size. X equals chunk C dot, what is it called? Chunks. Usually pluralized. Chunks of C dot x0 plus I. 1 equals chunks of C dot y0 plus j. So now we should be drawing them in a different order, but it should be identical looking. If I didn't screw up, I screwed up. They do change. They do have different values. Oh, because I'm using I and J here. Okay. these are now I and J. Oh, yeah, no. These are X and Y. And int I equals X plus radius, and J equals Y plus radius. That should fix it. There was a warning. That's probably bad. J is unref. Oh, yeah. I have to restart. So this I and J, hide this I and J. Revealing that bug. Ugh, this, I don't know why this is happening now. Why I'm getting this bogus stack. Am I... Am I writing off of indices? Is this loop running too long? Yeah, right here. Yeah, looks correct. Okay, so in theory, I'm drawing the same thing, but in a different order. And we used to have a way to draw so let's use hack 2 again. So hack 2 drawing if hack 2 and hack 2 times 3 is less than ring indices count of n, and we draw hack 2 times 3. Something was wrong there. Okay, so we're drawing them in a rotating arc around the viewer, which is how we're going to be able to do some efficient frustum culling eventually. So that looks right. So now when we get here, we need to store we need to reject the entire chunk? No. I'm suddenly really tired. We need to store for each index buffer which indices correspond to which chunk. So static int chunk start index 5 max chunks chunk start index of we need to know which number this is. Oh, I guess we could pass in. Let's just do it. We pass in buffer number. And then the start index for buffer number equals slot. Sub C. Now when we draw, if we want to do the naive version of this first, we can say, let's see, for C equals 0, C less than num chunks. Start equals chunk start index of n of C, and end equals chunk start index of n of C plus 1. And then your GL draw elements end minus start, and the start point and start times 4, because I think it's in bytes, and tries is end minus start over 3. So this will be just slower because we're just drawing the exact same thing. We're just we're just drawing it in lots of little batches. So like, for example, we could draw every other one. If C and 1 is 0, continue. And it's just drawing random holes effectively. So now, instead of randomly not drawing some, we frustum cull. So we need to get the frustum planes and test that against the chunk coordinates. And I think I'm too tired. I think I need a nap. So, gonna surprise and stop. D2 should be B arrow. Yeah, probably. Unless that's something I already fixed. Yeah, it was something I already fixed. Oh, right. Yeah, we already looked past that. All right. So, yeah, sorry for people who just showed up, but I think I'm going to bail because I'm sleepy. But we're now drawing in little 8x chunks. So let's go ahead and go to the whiteboard and just explain what's going on. And then we'll wrap after I explain it. So we're drawing a ring. Which is made up of lots of little quads, triangles. So we cluster those triangles into little groups of 8x8, which say look like this. Not the proportions of this are not correct, but whatever. So each of this is an 8x8 group of quads. And the reason that they're 8x8 is a minor performance thing. Instead of doing this down to every quad, we could do it down to every quad. But anyway, so now currently we're drawing each one of these with a totally separate batch, which is super inefficient. Although it's still plenty fast, but we'd like to do it smarter. So what we're going to do is frustum cull. So the camera is always somewhere near the center. And so the camera is going to be looking, like that. And we want to take each 8x8 if we look at that from the side, we're just going to probably assume it extends infinitely tall, or to the max height of the map. So it extends from 0 to, negative 1 kilometer to 8 kilometers tall, or something like that. And we'll test the frustum planes against it. So we'll do that for each of these things, and that way we won't draw any of these. And when your camera is tilted extremely, we'll start picking up some of these because this is too tall, but that's probably better than trying to worry about the actual heights of them. Uh, but the actual thing that we're going to do, that if you remember, we've sorted these squares so that the order that we draw them in is something like this. It goes one, well, it's kind of arbitrary on here, but let's do it on the right side. I wish I hadn't drawn all this in. All right, well, we'll do it on the red side. So the order that we draw them in is something like this: 1, 2, 3. Well, it's actually, oh, I see what it is. Okay, yeah, so it is actually this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what it is that there's a center point, and we're drawing that center point to the center of the map and sorting those edges so that we're sweeping a line, and we draw each grid square based on where the center is as it goes around. And the idea is that because the frustum is generally picking out in 2D, picking out these angles, then it means all the angles outside that we don't draw and all the angles inside it we do draw. Then it means that all the ones that we do draw are going to be adjacent in memory because we sorted them into that order, and therefore we can draw them all with one batch because they're all exactly next to each other. And we can do that if there is a direction you can look that crosses over the boundary, because it goes all the way around to here. So if you're drawing across the boundary, you'll actually need to draw 2 batches. And so then it's just a question of how you detect where the batches start that you need to draw and where they end. And for that, what we'll probably do is we'll probably take them in sorted order and merge them into larger groups. So like, something like that. However exactly they sort. And frustum cull detect on the larger groups. To determine which sets are visible, and then pick what's the minimum number of things to draw to cover all of the ones that are visible. Something like that. That's the plan. The camera, so the camera is limited to move in a small distance around that because the ring moves with the camera. So the camera is always near the origin, so the angles basically work, even though the angles are sorted against the origin and the camera isn't quite at the origin, but it's going to be close enough for that stuff to work. Yeah, this is the terrain engine. This is this thing. Which draws these successive rings. And so then the innermost one, the innermost object that you draw actually has all these and this, And so we'll just apply the same logic to the outer half of it, but the inner half we'll just draw always, all of them. Just as it's not worth it. I didn't switch views, so as you move, the ring is moving around you. Yeah, there we go. So if I run, that's what's happening in the innermost ring. Here's 2 rings, and then 3 rings, and then 4 rings, and 5. So, I mean, it's not the appearance of travel, it is travel. The camera does not stay next to the origin of world space, but it's staying next to the origin. The rings are centered, or the rings are moved next to the camera, so the ring origins, the camera is always near the ring origins, but not the world origin. The height map is taken from real world data. Here's a better view of the real world data for the height map. From a different engine. But this is the same height map as that other one. So you can see a riverbed and the steps, or whatever they're called. Oh, no, that's not what step means. Okay. I don't know what they're called, the terraced, that terraced thing. They have some name, but I don't know what it is. I cannot find a good term for it. There must be a term for it, but anywho, so that's it. I'm too sleepy. I gotta take a nap. Short stream. But we got stuff done. What did we get done? Generate vertex data more smartly. And begin frustum culling. I may do the rest of the frustum culling off stream, I'm not sure. And maybe we'll do a voxel Friday tomorrow. I'm not sure. All right, that's it. See you later. Bye-bye. Good night. Have fun. Thanks for being here.